So hello everyone, welcome again to this ACUMEN webinar. So the aim of today is really to hear from the lesson learned from our 4 pilots. So for the housekeeping rules, as I just said, the webinar is currently being recorded. Microphones are on mute, cameras are off, and just for the speakers, and please use the chat. The agenda for today, so I will quickly reintroduce the project for those who are not so familiar with it, and then I leave directly the floor to our 4 pilots, and we'll finish with a Q&A session. If you have some immediate comments to the presentation, just please write them in the chat. I'll see if I take them right away or I'll wait for the Q&A session. So for the project overview, so now the ACUMEN project, it began in 2023 and it's slowly coming to an end because it's finishing at the end of May this year. And most of the technical work have been done so far. The pilots are also reaching the end. But just to give you a bit the context of what was done up to now, so there was a lot of technical work done for the how to use AI in traffic management. So this indeed and the project was targeting traffic management for passengers and for goods. Most of the technical work was done on the data framework. So indeed, the aim was to facilitate the real-time information sharing among the different mobility providers and operators working on the project. And then there was a whole part of the work that was on the advanced monitoring and the forecasting to analyze and to predict the different traffic patterns and to understand what could be the different management strategies to ease the traffic. And this led to the creation of different solutions for the cities and to smoother a bit the traffic management operation in the cities. In a nutshell, these methodological components, so this data, this demand forecasting, were all put in a single ACUMEN digital twin. The different bundles are now being integrated, and it will be done for the end of the project. And then a lot of simulation was tested in the pilots. What is coming for the project still in terms of communication and different learnings that you can have by the end of the project. So there will be another webinar on governance because there was a lot of work done as well on this part and how to create and to help the cities to assess their AI readiness. There was an AI readiness tool that was created. So this should happen later in March. It should be done also with the Synchromode project. So we are now trying to find the best dates. And first and foremost, it will be the joint final event for ACUMEN and Synchromode at the end of April, so 21st, 22nd April. Here we really want it to be open to a large audience, to all the other sister projects, to the traffic management stakeholders, to the academic researchers, to the industry, to policymakers. So for all the ecosystem to learn about the different project results and also to confront them with some other publication that could have been made, other tools that would be created to really create a discussion. So we have quite a good ambition for this event. So we're going to send all the information soon about the save the dates for you to organize your travels and to try to reach as wide as we can in the network. There will be also a call for papers that will be launched in February. So stay tuned. We'll give you more news on this. But now back to the core of this webinar, that are the pilot demonstration and the learnings at this stage of the project. So we'll first hear from Helsinki, where the pilot focuses on incentivizing users thanks to an app. Then we will hear from Luxembourg with the optimization of the we will hear mainly about the autonomous shuttle and the on-demand services. For Amsterdam, here the core was on how to deal with disruption of the traffic, especially with the tunnel. And Mara is going to explain us this. And for Athens, it was a full simulation model that will be explained by ATUA. So please, I will give you the floor right now to Francesco Vitale from Aalto University for the Helsinki pilots. Please, Francesco.
Hello and welcome to the presentation of a Helsinki pilot, where we'll see how to incentivize users to use more sustainable transport modes via a traffic-related app. Next slide, please. So I will give you an overview of the pilot, then the description and activities, and then we'll see what are the main achievements and next steps. And here you can see a picture of the location of the pilot, which is the Jätkäsaari area. Next slide. Which is an area in Helsinki and is a complex transport hub with challenges for congestion and sustainability. And we want to promote some soft traffic management, where soft means that we are not enforcing any rules or limitation. We are just incentivizing users to use other means of transport other than cars in a seamless and informed way. And the expected results are the implementation of AI-driven nudges incentives to a better efficiency and sustainability. Next slide. These are the partners of the pilot. So Forum Virum is the pilot lead. Then we have Mobilisys with providing drone data, HERE Technologies providing probe and speed data, Aalto University developing assessment tools and conceptual framework, and AIMSON developing a simulation model of the Jätkäsaari network. Next. Next again. So a little bit more in detail of the pilot. We have a ferry terminal in this area, and whenever ferries depart or arrive, traffic congestion increase and there are interruptions in demand. So next. We can see that our objectives are to tackle sustainability, so address traffic congestion, and also improve traveler well-being, so enhance multimodal seamlessness and reduce public transport crowdedness. And these two objectives fall into the categories or the strategies we're implementing about nudges and incentives. And one more objective is to identify requirements and interfaces needed for the integration of our methods within the ACUMEN digital twin. So the data collected is already said, drone data by Mobilisys and speed and probe data by HERE Technologies, but we had also Bluetooth, passengers and vehicle flow data. We had a manual count that were used for ground truth data for validating our methods, and real-time commuter train data that were used again as ground truth data. And we had also these PayIQ ticket apps that were providing us with ticket sales, trips, and tram delays data. Next. So as regards to drone data, you can see here in the picture here in the middle, we have in the colored rectangles is the location of the drones. We've had 3 campaigns, data collection campaigns in September 2023, 24, and 25. And you can see here some results on the right, where at around 8:15, 9:45, and 15:40, there were some ferry arriving, so the number of vehicles increased and there was some congestion. Next slide. We had Bluetooth sensor data that were installed by Forum Virum and were used in our data fusion models that I will talk about later. Next, we have a manual passenger count that were collected during 2 sessions in afternoon peak hours, recording number of passengers entering and exiting tram vehicles. And these are also used as ground truth data. Next one. And then we have here data that were used to calibrate the AIMSON simulation model that we have, and they contain up to 5 years of historical data availability. And then we go with the experiment we run in September and October 2024 with this app where users were offered the possibility to gain some points that they can later use, for example, for cinema tickets and so on. So for every 5 kilograms of CO2 saved, they would gain 1 point. And this saving was when a user would choose to utilize public transportation instead of car. Next slide. Here we see the data collected with the app. Unfortunately, we didn't have too many users, but still we can see the results that the cumulative number of CO2 saving points was increasing until the end of the study period. But now that we have all these data, we have to make sense of them, and to do so we have developed some data fusion techniques. And in particular, we have estimated the number of passengers that were actually boarding public transport through a machine learning-based framework, and by integrating different data sets from Bluetooth, manual counts, drone, etc. Next slide. And you can see here a little bit more technical part on the left. You have all these data sets that were fed into the data fusion module, and then they were fed into the estimation module. We can see that we have utilized 4 different machine learning methods, the first of which, the linear regression, is the simplest one. You can see the results on the plot on the top left. Not very accurate, but with the other 3 models we have used, we got very accurate results of estimating the number of passengers. Next one. Once we're done with the data fusion, we have gone to the actual implementation of the optimal incentives strategy through an optimization model that was minimizing the total travel time, taking care of traffic assignment, model share, and optimal incentives. Next slide. Here we can see some preliminary results of the method utilized in Jätkäsaari. We see that, so the budget, first of all, is the number of hours that a user is willing to switch from car to public transport. And we see that if we give a higher budget, then the total travel time is reduced, and the total share of public transport, of course, is increasing, which is a good thing. Next slide. This is very important, especially for decision makers. We can have an actual visualization of the break-even point when the benefits is equal to the cost, and we see that the plot on the bottom, we have the most of the total travel time reduction already for lower budget. So when we are still in the green area, so the benefits are higher than the cost, which is a very good thing. Next slide. And as already said, Aimson has developed a model for Jätkäsaari network, and we are planning to integrate our incentives strategy within this model in the near future. Next one. Other activities that we have had in the pilot include workshop with the stakeholders, as well as other activities with digital twin. Helsinki has its own digital twin, so there was some collaboration with the ACUMEN one. We have implemented the mobile app experiment. We have installed the devices for the tram stations, as already said, and we have organized events, seminars, papers. And if we go to the next slide, we can see the pictures of some of these events. And next slide again. Here we have a more comprehensive list of all the partners that were somehow involved in the pilot at different stages of it. And if we go on, to conclude, we can see that the key achievements were we completed the drone data collection campaigns, 3 out of the 3 that were originally planned. We have collected and harmonized multi-source data set, and we have used them to develop sophisticated data fusion framework. Then we have designed novel mode choice incentive strategy, and we have replicated the pilot site in a simulation model. So what's left for the future is to continue the digital twin integration. We have already integrated some of the components. We will continue doing so. And we want to, as already mentioned, we want to test the incentive strategy in the simulating scenarios model provided by AIMS. That's all from my side. Thank you for listening.
Thank you very much, Francesco. Really clear presentation with really interesting part of the different types of data that were used, fused, and also this interaction with the really the citizens throughout the pilots. I think it was really a really interesting part of this Helsinki experimentations. I don't see immediate question in the chat, so I will go directly to the next presentation, and we'll have time to discuss during the Q&A. So please now welcome Francesco Vitti to explain the Luxembourg pilot.
Thank you very much. So we move from one Francesco to another. So yeah, here is the main take-up messages of the Luxembourg pilot. So the Luxembourg pilot has the main objective of demonstrating the impact of door-to-door connectivity and automation in multimodal services, especially for synchronizing and efficiently moving from one mode of transport to another. And in particular, our focus is mainly on optimizing on-demand services, and in particular for last and first mile connectivity to mass transit services. We do that by looking, please stay on the previous slide. So we look at by actually two different specific case studies. So one is an activity area located in about 10 kilometers far away from Luxembourg capital city, a municipality called Kontern, where a certain number of employers and offices are located. And then the main objective is to actually connect these offices to the main train station of St. Weiler Kontern. Whereas the second case study and location is within a specific pedestrian area in the city center of the second biggest city of Luxembourg, Esch-sur-Alzette. And it's also having a relatively different purpose than the previous one. It is also, let's say, a local service, but then it has two purposes. One is to let people move within this pedestrian area alongside a very popular shopping area of this city, of this town. And the second is to also connect to the train station of Esch-sur-Alzette, which is also located close to these shopping streets. So in both cases, we are using on-demand services, or at least we want to upgrade the existing services to make them flexible and on-demand, and then to seamlessly connect them to mass transit. Our main partner in these pilot projects, and especially the one that is behind all the operations and the technological development, is our ACUMEN partner, Thales Lens, who is one of the biggest private public transport operators operating in Luxembourg. So this is what we are going to showcase. Well, the two case studies, they show relatively two different things and added value services within multimodal public transport. So the first one is to prove that integration of information and integration of and synchronization of scheduled services, train systems, with let's say on-demand services in low-demand areas like Kontern can produce a lot of benefits, both for the operator and for the passengers. And the second is actually the service in H2Z is using an autonomous bus. And then we want to demonstrate the technical feasibility of making this autonomous bus also on demand. And in particular, being able to pick up and deliver the passengers in a more flexible way, skipping also stops where there are no passengers requesting to be dropped off or picked up. Please go ahead. So these are the 4 main activities that we have been doing in the last years. So the first 2 are belonging to the Contern. So the first one is the real-life implementation of on-demand service, and then the development of the on-demand application that is currently used by the employees and the employers within the Contern activity area. And the second is to identify, let's say, the strengths and weaknesses of on-demand services by also looking at all potential demand patterns, which of course we cannot observe in real life. And then using the stress test scenarios, playing with different demand spatially and temporally, and then generating different type of KPIs to prove the overall benefit of on-demand services with respect to fixed schedules. The last 2 will belong to the H2Z. So the first one is a study on social readiness of autonomous on-demand service. We particularly collected on-field stated preference data with the users of the autonomous shuttle. And the second is the technical readiness of the autonomous shuttle by testing the on-demand app originally developed in Contern. We have been testing it in H2Z, and now we are in the phase of testing all the functionalities related to stop skipping. Please go ahead. Okay, very briefly, so we can see the Contern. You can see the map. Actually, the service that was already pre-existing before we started with the ACUMEN pilot was to move from the campus Contern area, pick up people within this area, and then move them to the train station, which is located a bit further away, around, I believe, 4 kilometers far away from the activity area. So the service has been running continuously every day, every working day from 7 o'clock in the morning to 8 o'clock in the evening. And the original frequency is every 10 minutes. So it is quite a frequent service, especially for the low demand of that area. And you can imagine particularly expensive for the operator. Now we are moving then this fixed service to an efficient demand responsive transport, an efficient on-demand service. This service has started and is up and running since March 2025, where in particular during the low demand times, so in between 11 a.m. and 3 p.m., the service is only running based on requests coming from the ACUMEN app developed by our partner Thales Lens. The campus Contern has requested to remain with fixed schedule during the peak time, so we have also the opportunity to compare the service in fixed and daily schedules on the same day. Please go ahead. So we've been running this and collecting the data and receiving all this information. And then what I did not mention in the previous slide is that all this information is now being embedded into the digital twins. All the data that we are collecting regarding demand request, our partner Thales Lens is sending it into our digital twin. So we have been enhancing the real life scenario with different scenarios coming through an agent-based simulation software, MatSim, where we are using the demand patterns that we have collected in real life, and then we have been varying these demand patterns with very low conditions, like minimum 20 customers per day, to a maximum of 500 customers per day. And then we have been changing the different places where these customers request to be picked up within the campus content. This allows us to also show the impact of optimizing the service. We have been using efficient meteoristics to optimize the service schedules. And then we've been also using agent-based simulation because Maxima allows us to also make more choice. So we also can integrate in this service the opportunity to change mode of transport. If the users are not happy with the on-demand service, they can use another mode, like, for example, the car. And then we have been collecting different KPIs, including efficiency, travel time, waiting time, walking time. So the passenger perspective. Please go ahead. So just briefly, you can also probably skip the animation regarding the different KPIs. I think the main thing that this table, the main take-up message is that when we are moving from a fixed service, the existing one that you have on the left side, to the on-demand service, many of the aspects are improving. For example, the walking time of the user are extremely lower, as well as, more in particular, what we do is that we have a much more reliable connection, which means that the users have a much less chance to lose their connection with the train service. So the connecting ratio is way lower. And then you can also see that this is particularly desirable for the operator, the vehicle kilometer traveled by the buses, especially when you have relatively lower number of customers. So in particular, in the moments where on-demand services are really needed, the buses run much less kilometers, which means less emissions, less cost for the operator. Okay, you can skip the animation and then go forward because we are running out of time. Now, next step here for the simulation program is actually that we are investing again on simulation mixed use of the service. So the service will not only be used by human passengers, but will also be used by moving packages along the content area. And this is done using also simulation to show that mixed use could also help us at making the service more efficient in terms of cost to efficiency ratio. Okay, go ahead. Now, moving to the second, the autonomous shuttle moves along this corridor that you can see on the picture. There are 6 stops, and then the total length is about 1 kilometer on these shopping streets, which is used by the cars only on the transversal roads. Now, this service is a service that moves again on fixed times of the day, and it's pretty much used. You can see from the table the number of passengers that they have been using it is not too bad, considering that is operating on a small area. Now, what we did with this project was to move or to test the application, the on-demand app, to actually prove the connectivity with the application and the autonomous vehicle. That was done in September. And then we are now testing the stop skipping and selection. So based on the actual request, the bus will or will not stop to the different stops, so to make it more efficient use, and will also pick up the people at the time they are requesting the ride instead of running in a fixed service. Please go ahead. Now, the other part of this project related to the Ash area is social readiness. So we have been collecting data. Around 115 users have been so kind to give us their opinion about the satisfaction regarding this service. And then this was done at the time the service was up and running for quite a few months. So these users are mostly regular users of the autonomous bus. We have been collecting different type of perception regarding safety, regarding accessibility, but also regarding the potential use of this service in the future for on-demand. Okay, go ahead. So the main results and take-up message for this is that actually this service is considered a very good service, especially for people who, with low mobility opportunities, disabled or aged population. It is also a very good service for improving the accessibility in general of all the user, and it is seen as quite a good extension of the existing public transport service. So in general, people are relatively happy with the integration of these autonomous service, in particular in these areas where mobility is mostly done by walking and not by motorized modes. Okay, go ahead. What is interesting is that we asked to the users, what do you think if this type of service becomes on demand? And then you can see that actually there is some kind of, I would say, discording behavior. Let's say the people there is quite some people that actually would prefer to make it a fixed schedule. They do not see the added value of making this service on demand, but this is only a small percentage, around 25%. Whereas the largest majority, they do prefer and they do see an increasing flexibility of the service, especially because they would be able to be picked up and dropped off in the location they really want and not in a fixed location. And then they do believe that waiting times will reduce, showing also that they will have a benefit in terms of total journey time. Okay, move ahead. I think we are now to the last one, which is where we stand now. So in September and in December, we did some testing on the opportunity to make requests directly going into the autonomous vehicle. You can see the picture of our colleague from Thales Lens, who is showing the back end of the autonomous vehicle, and showing also that one customer request has been recorded and is being identified on the back end. So now the bus is ready to actually replan and reschedule the stops. And in February, March, we will be able to record a demonstration video where these will be fully functioning. Okay, I think the last slide is to thank everybody.
Thanks a lot, Francesco. Yeah, this Luxembourg pilot, I think it's really, really interesting learnings on how to assess the different advantages of the on-demand service versus the fixed one to reduce the costs. And but it really requires assessment to be sure that it's used the best way. And I really like for the this AV pilot that it's really analyzed with all the different aspects, like the technical one, societal one, like all the components are there to really do the good assessments. Yeah, we're already a bit behind schedule, so I'll leave the floor directly to Mara for the Amsterdam Institute for the Amsterdam pilots. Please, Mara, go ahead.
Thank you. First of all, good morning all. My name is Mara Hafkort and I work at AMS Institute as a Living Lab Manager. And today I'm going to briefly update you on the Amsterdam pilot within ACUMEN. And in this pilot, we're exploring whether joint multimodal traffic management can help the city to better deal with major network disruptions, and whether the simulation-based approach can actually help us to develop this. So two things that are good to mention up front. This is a fully virtual pilot, other than the other pilots in ACUMEN, and the model is still under development due to delays. So today is about the directions of the simulations rather than the final results. Nevertheless, we're really keen to hear your feedback on whether this approach is valid and whether you potentially could also use this in the future. So next, let me explain the use case that we are focusing on to test the simulation. In this pilot, we are focusing on the I-Tunnel corridor, which connects Amsterdam North and South. And as you can see here, it's actually a critical link because the river strongly limits the number of crossings. And when the tunnel is disrupted, the current response, which you can also see here, is to mainly divert cars via the ring road, often causing congestion and longer travel times. So the key to this question, the key to this pilot is, can we manage the I-tunnel disruptions better by looking beyond the road network alone and including also other transport modalities? So let me explain the relevance of the other modalities in this case. If you can go to the next slide, please. So what makes this case particularly interesting is that the tunnel is not the only way to cross the I, because in parallel to the road connection, there's actually also a high frequency metro line connecting Amsterdam North and South. And crucially, this metro line continues to operate also when the I-tunnel is closed. So this raises the question, what if we actually use this alternative cross-I connection as part of the disruption management strategy? And there's also an important behavioral aspect to this, because disruptions are moments when travelers are more willing to reconsider their choices, their travel choices. So if their use is usual to take the car, they may switch to public transport. And sometimes this change could even last. So it can be considered a window of opportunity for interventions to stimulate public transport use. And it's actually a pity that we do not currently make good use of such opportunities. Also considering the ambitions of the cities to lower the car use in the city. So our approach is to stimulate the road traffic and public transport together and test how coordinated multimodal strategies could perform during tunnel disruptions. So in the next slide, we show what we are building. So we're building a digital twin to simulate the multimodal interventions and see if it improves the traffic flow. We build a traffic network based in Sumo, and the road network is based on OpenStreetMap, but it requires substantial manual adjustments to improve the intersections, and we had to manually include the traffic lights. And the other bottleneck was that the public transport network proved to be more complex because of data quality issues. So now TU Delft is actually rebuilding the public network from scratch. And once finished, this should give us a reliable base for the multimodal analysis. So with this clean road network, if you now move to the next slide, we can eventually run a traffic flow simulation in Amsterdam. The simulated traffic flow is based on TomTom data, but although this shows correctly where people travel from and to, at the moment, the traffic volumes are too high. And when we load the full demand, the network immediately enters a gridlock. So we're integrating loop detector data to improve the accuracy of the travel flow. And once this is corrected, the simulation can show the impact of several multimodal interventions on the traffic flow, such as the delay time, as you can see here. So the strategies that we want to test, if you can go to the next slide, are first of all route guidance, for example, steering travelers towards the park and ride and directing them to the metro line, but also intersection management, such as prioritizing public transport at traffic signals during disruptions, parameter control, using key intersections as a gate to protect network performance and prioritize public transport. And finally, incentives such as increasing the frequency of the metro line or testing temporary pricing measures. And the goal is to understand how these strategies work together rather than in isolation and how it could improve the overall performance. So if you go to the next slide. So what I already mentioned is that we haven't been able to test the interventions yet because of two remaining bottlenecks. And the first is a demand calibration. So the original data, when we uploaded it, it enters gridlock. So we're trying to improve that. And we still need to finish the public transport network. But once these two issues are resolved, we can really test the multimodal interventions. So finally, what we would like to ask you, so the goal of the simulation is to explore how multimodal strategies could improve the management of major disruptions across the I. And based on what you've seen or what we've just shared, we're just curious to hear if such an approach would be valid and practically useful, even though the simulation is not yet finished. So we don't really have time to dive deep into this question right now. But if you have any suggestions, feel free to share it in the chat or maybe get back to us at a later point.
Thanks a lot, Mara. Yeah, on this Amsterdam pilot, yeah, the most interesting is like just to try to anticipate all different modes, go for a switch really quickly from one to the other, metro, tunnel. So that's really the complexity and yeah, and the whole aim of the simulation. So yeah, it would be interesting to hear from cities that have a bit the same structure of public transport to understand if it can be of help. But yeah, for the sake of time, I will already switch to the Athens pilots, and we'll see if we can discuss it later on during the Q&A. So please, Panayotis, I will leave you the floor. So from NTUA to present us this pilot in Athens.
Yes. Hello, everyone. My name is Panagiotis Pafoutelis. I am a postdoctoral researcher at the National Technical University of Athens. And within the framework of ACUMEN project, I am involved in Athens pilot and all relative developments. My colleagues and I have prepared a presentation about what we are going to implement in Athens. The main objective of this pilot is to develop an innovative holistic mobility platform that will provide all the necessary information and tools to support decision making and also dynamic traffic management. The implementation and testing of the modules would refer to the broader area of Athens and would consider various modes, including private cars, motorcycles, trucks, delivery vehicles, as well as public transport services. The target users are transport authorities, also policymakers and other relevant stakeholders and operators. And the scope of this pilot is to investigate the acceptance of the entire scheme and integrate it into a digital twin of the city to test its effectiveness in various scenarios. For those that are not familiar with the project, the organizations that are involved in the Athens pilot are the AEM, which is an SME of the municipality of Athens and is the leader of the pilot, and the UA, which serves as the scientific advisor and also has developed the simulation model of Athens and several other modules for the project. Here we'll provide additional traffic data. Mobilities collects trajectory data using drones, and we'll also do the relevant analysis. UG also develops a module, and EMSAN provides the simulation platform. The next one. First of all, let me tell you a few things about the current situation. As you know, Athens is a very old city and has a very complex and unstructured road network, especially close to the city center, where some of the streets we can say that are literally ancient. So after the pandemic, we have observed a significant increase in private vehicle usage and congestion, which is also partially due to some economic growth after almost 10 years of financial crisis. So we have heavy congestion, especially during peak hours, while the duration of the peak hours is always increasing due to the high demand that cannot be served. And also there is a lack of efficient traffic management and real-time data transmission and communication. And all of this together make the traffic conditions unsustainable at the moment. The next slide. So what we have designed for Athens is a toolbox of different modules that refer to a lot of different aspects of traffic management and monitoring. They are all based on novel and beyond the state-of-the-art techniques that could help in decision-making and in more effective and efficient traffic management. So specifically, we have Drones that fly above critical areas of the road network and collect trajectory data mainly for monitoring purposes. Also, we have developed a real-time incident detection model which can detect patterns that are associated with incidents, such as road accidents, almost as soon as they emerge, and traffic forecasting models that provide very accurate estimation of the traffic condition in future drive time periods. Also, we have developed some AI-based techniques for traffic management that have the potential to alleviate congestion at a significant level. The next. This is the study area of the pilot. With the blue shade is the protected network of the city center. With orange, the measurement stations where we collect data about the number of passing vehicles and their speeds. And in addition, we use trajectory data from drones and probe vehicles, as well as the schedules of public transport services. The next one. For the drone experiment that I mentioned before, we have first defined 9 areas of interest, which are critical locations of the road network with increased demand, and used 8 drones to record the traffic conditions. The experiment took place in May of 2024 for 5 hours per day, and we collected a massive dataset of about 6 terabytes of video, which were analyzed, and the trajectories of all the vehicles were extracted in a more convenient format. And currently, we are performing an analysis on the effect of delivery vehicles and on-street parking on traffic conditions, and we expect very interesting outcomes. The next one. For the incident detection, we have developed a framework based on unsupervised learning techniques, which first recognizes the daily typical traffic conditions pattern for all locations, and then it categorizes the current conditions based on their deviation from the typical pattern. We have identified 4 related categories, which are the typical recurrent conditions, low demand, boundary conditions, which occur typically before or after heavy congestion, and non-recurrent heavily congested conditions, which correspond to a possible road incident. We use high-resolution data with a frequency of 90 seconds, which means that we can almost in real time classify traffic conditions into one of the above categories and therefore detect an incident very quickly. The next. For the forecasting model, we have combined some aspects of traffic flow theory with powerful deep learning models, which enhanced significantly their performance and also the model's trustworthiness. Technically speaking, to do that, we have designed a loss function that takes into account the distance of the prediction from the fundamental diagram of traffic flow theory. And with these models, the decision maker will have an accurate estimation of the future traffic conditions and will be able to take action and probably prevent congestion in some cases. The next. Furthermore, we have developed a user-friendly interface that visualizes the evolution of traffic conditions and provides predictions using the aforementioned models. So if there is high uncertainty about a prediction or the algorithm detects non-recurrent traffic conditions, it warns a human user who should intervene and help the model improve its prediction. With this framework, we expect to further increase the accuracy of the predictions, which is very important because these outcomes will be used for traffic management and decision making. The next one. Finally, we have the traffic management strategies, which are based on artificial intelligence algorithms, and 3 levels of interventions. First, there is a solution at the intersection level, where we have identified some critical intersections that get congested and implemented the max pressure algorithm to give priority to buses. Next, at the corridor level, we have designed a solution to control the density of bus lanes based on deep reinforcement learning, which in simple words allows a number of private vehicles to enter the bus lanes in situations where it would not cause delays to the buses. And that way it improves the traffic conditions of the road section. And lastly, we have implemented a hierarchical approach of perimeter control, which controls the number of vehicles that enter and exit the protected area of the Athens network, and again, giving priority to public transport. The next. Yes, very quickly, some preliminary results of testing the previous approaches in simulation environments indicate that the combination of all the above methodologies could decrease the travel times by about 30%, and especially the main benefits are during peak hours and during disruptions compared to business as usual. And the next one. Yes, as I mentioned, the final step is to integrate all these modules into a digital twin of Athens, which is a visualization of the simulation traffic model and the outcomes of the submodules. For example, the user would be able to see the predictions and incidents that are detected. This is a very useful tool because it is a user-friendly and understandable way to observe the operation of the modules. So we plan to provide this platform to actual policymakers and authorities in order to get their feedback regarding the usefulness in decision making, and also we will test all the entire framework in various conditions. Thank you.
Thanks a lot, Panagiotis. So indeed, this Athens pilot was a bit more technical for all the simulation parts, but I think it will be really interesting to have maybe something like a live demo of this digital twin, especially during the final events. I think to have it in hand and understand, and just visualize all the different elements directly on the tool. But thanks again also for explaining. So one of the core of the ACUMEN project is indeed to use AI for traffic management, and here in the Athens pilot it's really clear at exactly which part of the traffic can be managed with AI for the intersection level, at the corridor level, at the network one. So that's really some interesting learnings on this. We have still 4 minutes on time for the Q&A session. I don't know if you still want to add some questions in the chat, but maybe first I wanted to begin with one key question that I want to ask to all pilot leaders. Is now that we are at the end of the project, and we have in the audience some cities that are also asking themselves how to use AI for traffic management. If they want to replicate some of these experiments in their own cities, what would you advise them? Like really the key challenges that you had, the key learning. What would be like your 3 advice to cities that want to run such experimentation? I don't know who wants to start. Francesco, maybe from Helsinki, as we discussed.
Yeah. So from personal experience, I would say try to invest more in getting more data from users. For example, in our case, when we used the mobile app, we couldn't get enough users. And this is because if you want to incentivize them to shift to public transport, for example, or anyways, a more sustainable mode, you need to actually understand what is their behavior, what is their attitude towards transport. And this can be different from city to city because, I don't know, maybe if you are in Amsterdam and public transportation is more crowded than Helsinki, so you never know what is, the threshold that the users are actually capable of bearing. So that's the main.
Yeah. Okay, main takeaway from Helsinki. Okay. Good. Maybe I don't know. For Luxembourg, any advice that you would give to run such experimentation in another city?
Well, the one main advice that I would give, and one main challenge that I would see also, is that it is important to provide the right communication and dissemination for all the things that are being implemented in order to guarantee an increased engagement of the potential users. Sometimes, especially when you're dealing with public transport or multimodal transport systems, the lack of information or the awareness of the existence or all these services might be one of the causes why these services have the tendency to fail. So we did experience these type of challenges, or we are still experiencing these type of challenges with our pilots, because it is important that the potential passengers and the customers, or also the citizen who are walking in these shopping streets, they constantly are aware that there is a service made for us and that it constantly improves only when this is used. And this is particularly important when you are using applications, mobile applications, because in that respect, of course, an app, a requesting app can learn and can identify solutions for improving the services only when this app is used. Otherwise, the service will not be efficient, effective.
Okay, thanks a lot. So strong incentive on communication and having all the stakeholders always participating to iterate. Yeah, no feedback, no possible iteration indeed. Amsterdam or Athens, any advice you'd like to share?
Yes, from our side, from Athens, most of the modules that we have developed, especially the traffic management, were developed and tested in a simulation environment. But this is mainly because the necessary infrastructure to implement them in real-world conditions, for example, connected infrastructure and vehicle-to-infrastructure communication, are not available at the moment in most cities, but are expected to be in the near future. So sooner or later, we would be able to actually apply some of these solutions in real conditions. So I would also like to say that the most important part for us that we are now developing the models, but also for those that are going to use them, is that the seamless availability of the required data is ensured by the cities, the authorities that operate the road network.
Okay, thank you. So indeed, yeah, even if in total simulation environment, just always think about collecting as much possible data from real world to be sure that then it can be applied like really quickly to current and concrete situation. Yeah, we are already running out of time. Mara, any final words? I know that there are still some work on the pilot, so maybe not all the advice are ready yet. But
no, but I think in general it's very important to involve the stakeholders and the different operators as early as possible, so that you have also their experience and their expertise on board.
Okay, great. So that will be the last and final comments. So yeah, make sure that you don't develop things on your end just for you, just for academic purposes, but really that's its answers will challenge in the city, and all stakeholders, citizens, operators, our public authorities also are involved to iterate and to make sure that the feedback loop is working, and because the objective will be collectively reached. It's not only one stakeholder who can do the whole work. Thanks again to all our speakers for this really clear presentation of the pilot learnings. It was really good to hear them, and for the people to join online. All the last results from this pilot that will close soon will be also displayed during the final event of ACUMEN and Synchro that will take place in April 21st, 22nd in Brussels. So make sure to join. We will also invite a lot of different other partners from other sister projects and from the traffic management ecosystem to confront those different learnings and pursue the discussion. So thanks a lot again, everybody, for today, and enjoy the rest of your day. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.